That's okay. Everyone's on hold until we start in just a minute here. Everybody's muted.
Okay. Sorry, I missed that.
It's okay. It's early. All right. Good morning, everybody, or good afternoon, as it were, depending upon where you are in the world. Thanks for joining us today. We've got a lot to do and have a really exciting event planned. We have a Google Hangout event or a virtual field trip with Schmidt Ocean Institute. So Careers at Sea with the Schmidt Ocean Institute. And my name is Stacy Rafalowski. I'm the Director of Programs for EarthEcho and Echo International. And we're super excited to have classrooms from across the world that are joining us today as we explore the research vessel Falkor and learn a little bit more about the research and the careers of the people that are working on the ship. So before we get started today, this is going to be an event that takes about 40 minutes or so, and we want to do a little bit of housekeeping on the front end. So we want participation from everyone that's watching. So we want you to be able to ask questions. We've got 2 wonderful classrooms that are on camera right now, but we know that there are a number of classrooms that are watching that aren't on camera. So if you're watching from a classroom that's not on camera, please make sure to interact with us and ask questions. There's a form if you're watching on the EarthEcho webpage that is just below the viewing screen. You can put in questions there and we will answer them on camera. There's also an app if you're watching on the YouTube live page. There's a chat app which is just to the right of the viewing screen as well. So you can put your questions in there and we will, as they populate, we'll ask during the course of the virtual field trip today. So please go ahead and post them now. If you just want to wave at somebody that you see out there, we'll definitely acknowledge your interaction with us online today. So now as we get started, I just want to introduce all of the different faces that you might see as we go through this event today. And first we've got Ms. Klein and Ms. Milliken's classes from Iolani School in Honolulu. You guys wave? We may have some additional classes. I don't know if I have all teachers represented there, but got a great big room there today. And then also joining us, we have Mr. Trogdon's class from Coventry Middle School in Akron, Ohio. Hi, guys. So we're really excited to have both of these groups able to talk with the Falkor today. And joining us live from the Falkor in the Pacific Ocean somewhere, we have Deborah Smith and Oliver Worrell and Luke McNutt. I think I muted you guys, so I'm gonna unmute you guys now. Or you might have to unmute yourselves. Well, we're gonna have to work on a little technical difficulty there.
Say that though.
There we go.
No.
Okay, perfect.
Now you're good.
Okay, sorry.
No worries. The wonders of technology.
We muted ourselves.
So today we're going to let each of these folks talk a bit more about the roles they play on board the ship, show us some awesome stuff behind them on the screens on board the ship, and talk a little bit about the research that's going on this particular cruise that they're on right now. So Deborah, will you get us started and give our classrooms a little more information about Schmidt Ocean Institute, the current expedition, ship?
Sure, absolutely. Well, first of all, welcome to the Falkor. We are currently just outside, just to the north of Darwin, Australia. And first, I'll talk a little bit about SOI. So SOI is a nonprofit organization that was founded to help develop ocean research through advanced technologies aboard the Falkor. It is a collaboration between the ship and shoreside personnel to really help scientists bring forward new technologies for ocean research, ocean conservation, and it just allows people an opportunity to have a place on a ship in the ocean to do this research. A little bit about the Falkor. The Falkor is 83 meters long, and I know a lot of you are in the United States, so that's part of your homework. Figure out how many feet that is. 13 meters wide. The maximum speed is 17 knots, although I've not been aboard when she's actually done 17. Typically, we're going somewhere between 8 to 12 knots. And typically, there's 22 to 24 crew on board. And the most people that we can have on board is 41, and we can go to sea for 36 days straight. But only 30 people can eat in the crew mess at the same time. So we'll talk a little bit more about life at sea and solve that problem.
So what is your role specifically, Deborah?
So aboard the vessel, I am a marine technician here at Schmidt Ocean Institute. I am actually one of our most recent crew members. I started in August of this year, but I have been aboard the Falkor twice before through my previous job. And my previous job was mapping the ocean floor. So I have most of my background is in ocean floor mapping. I've spent the last 14 years doing that in the United States. I went to school to Maine Maritime Academy, and I have a bachelor's of marine science. But while on board the Falkor, to take care of all the scientific equipment that's aboard, to make sure that it's running properly, that it keeps running, to help scientists integrate and mobilize their equipment when they come aboard. So every time we have a different science trip, we have different scientists with different equipment, or we have to teach them or show them how our equipment here on the vessel works. And so my job is to fix things when it's broken, come up with interesting solutions for science to help their equipment work better, and then just keep all of the science gear on board running, along with a team of 2 other marine technicians.
Okay, great. Does either of our classrooms have any questions for Deborah right now?
Oh, you have a question? We have a question here at Iolani in Hawaii.
All right. What's your question?
What kind of process does it take to clean out all the equipment?
So he's curious about cleaning out the equipment. What kind of processes do you use to clean out or change the equipment?
Yeah, so if I understand the question right, it's what sort of processes do we use to clean or to swap out equipment? So it really depends on what the different equipment is. So one of the things we have on board is a CTD, and the scientists on this trip are using that. They are using it to collect water samples. So CTD stands for conductivity, temperature, and depth. And it's an instrument that we put overboard. We send down to whatever the maximum depth that we can, that the water we're in. And then as the whole system is coming back up, we can trigger bottles. And that allows scientists to take different water samples at different depths. And so part of my responsibility is to make sure that each of the instruments on that CTD are working, and then also go out to calibration. So I might have to swap out different types depending on which parts of the ocean the scientists are looking at. And then also make sure that that's well maintained. So every time something comes out of the ocean, we typically wash it off with some fresh water. And then also, anytime a scientist brings along a suite of instruments, we also connect their instruments at times to our shipboard data networks and make sure that their data is backed up, as well as collect and store all of the data we collect here on the ship.
All right.
The question?
I think so. It doesn't seem like we have a follow-up. So I had a quick question. What do you like about your job? What are the things that you really like about having your job?
So one of the things I really like about my job is not every day is the same. I get to wake up and either solve a new problem or find out and research new information on a new piece of equipment. It's sort of always evolving and always changing, which is one of the reasons why I took this job. You know, I have been doing mapping for a very long time, so I'm very comfortable with that. And this job allows me to have a broader spectrum of ocean research and to see lots of different types of equipment. With Schmidt Ocean's really kind of advancing technologies, we get to do all sorts of new things. And I got to fly a drone the other day, so that's pretty cool.
That is very cool. I got a question while you were answering that question from Seattle, and it was, what do you like least about your job? So what are the challenges that you face?
Waking up at 3:30 in the morning. I think sometimes the least favorite is always constantly potentially changing your schedule. So Luke will talk a little bit more about this, and the scientists can talk about their schedules. But as an MT, I work 12 hours a day, and in any given trip, that might be noon to midnight, or that might be midnight to noon, or that might be 8 to 8, or vice versa. And so you're always sort of constantly shifting through a day. Once you get onto that shift, it's pretty much fine, but I'm not a morning person.
Understood. What about any other questions from the classroom or anything else you want to share, Deborah?
If there's more questions, I'm happy to answer questions.
We have one more question from
One more question. Yolani.
Can you tell us a bit more about the screens that are behind you and what we're seeing on those screens behind you?
Yeah, sure, absolutely. So the screen, sort of like the Weather Channel. I have to figure out which one to point at. The screen here on the upper, I guess you're right, is a map of where we are right now. But this program is just a website interface, and this entire website lets us monitor all the data being collected by the Falkor. So it will let us, Monica, if you can switch to like the weather tab up on, no, you can't, sorry.
That one's a little hard to see, I will say. That one's a little harder to see as far as the screen.
Little hard to see. So then, and on the screens, I'm going to turn around because I don't actually know what's on them. The lower screen is showing our aft deck, and the upper screen is showing different cameras. So all around the Falkor, we have cameras that allow us to see what kind of work is going on. And then also the one that looks very white right now is actually the position of the ship. And that website interface allows us to look at all the data. So we can look at all the weather data that's being collected by different sensors that are installed on the top of the mast on the middle of the ship and on the mast that's on the bow of the ship. And then also if we're collecting multi-beam data, we can bring up any kind of maps that we're currently creating. It also lets us, so the entire ship works on this matrix interface. So it lets us around the ship in different rooms put up any computer that we have on board and look at and run it. So it's a pretty neat system. Also something we have to figure out how to do when we start this job.
Very cool. I've gotten another question for you from Pace High School. And the question is actually, how stressful is it working at sea for long periods of time?
Well, one of the things we're typically very fortunate with on the Falkor is pretty decent internet service. So much like we are being able to talk to you guys around the world and in your classrooms, we can typically call home. So it's not terribly stressful. We get to touch base with family members, maybe have a Skype call or at least a Skype phone chat or a Google Hangout. Facebook works. So things like that let us keep in touch at home. But we do typically, my rotations are 2 to 3 months at a time. And then I get to go home for 2 to 3 months and spend some quality time with family.
Great. That's got to be a perk. in a lot of ways as well.
Yeah.
I want to let Mr. Trogdon's class know they have some questions, but you guys, you need to unmute from your device there. There you go. Nope, you were unmuted.
Good now?
Now you're good.
Are we good?
Oh, good.
Go for it.
Okay. I have a question. Okay. So what is one of the most complex problems that you've had to solve on the ship?
Can somebody repeat that? I don't think we quite heard it.
So what is one of the most complex problems that you've had to solve on the ship? Are you talking about like a research problem or like a technical problem?
Like scientific equipment, like, you know, stuff like that. Because you said
Like troubleshooting the equipment?
yes, exactly.
So they're
Yeah.
curious about
Okay.
troubleshooting.
Yeah, so I think one of the challenges for me, because I'm still so new and learning it, is sort of trying to figure out on any given equipment how it's sending data. So every piece of equipment out there can send data in different ways, whether it be via what they call an Ethernet cable or via serial cable. And so for me, one of the things I've been learning more and more about is how any instrument sends the data, how we then read that data, and then how we translate that into collecting the data. So really it's challenging because every instrument is different. You have to really read the manual or figure out what type of data string, you know, which each of the fields in the bit of data that's coming in mean, and then how to disseminate that into a file that scientists can read or software can read and be able to move it around the ship. So we might have installed an instrument on the top of the main mast, and then we have to be able to get that data all the way down into the science lab and logging into the computers. And so that's just different for every piece of equipment.
Thank you.
Oh, I think that's a great question to transition a little bit because we also have with us to talk a little bit more about the science that's going on with this particular cruise, Dr. Worrell, who is one of the principal investigators leading the research. And so if you don't mind, Dr. Worrell, we would love to hear a little more about why you're on board and what you've got going on.
Yeah, hello everyone. My name is Oliver Woll from the University of Oldenburg, northwest of Germany. We are here on board to investigate the exchange of greenhouse gases from the atmosphere to the ocean. And we are particularly looking at the very top layer of the ocean. You can imagine it as if you pour some oil on water, you will have a organic film. And this also happens on the ocean where tiny plants and animals excrete a lot of molecules, and some of those molecules behave like oil and just accumulate on the sea surface, having or making those films, and those films will slow down the gas exchange. For example, from carbon dioxide, which is very water soluble. And we look at those processes, how the sea surface controls this gas exchange.
Okay. Well, I'm going to ask, because that's a lot of information all at one time. So I'm going to ask the classrooms, do you have any follow-up questions about that specifically?
We have a couple questions.
Fantastic.
Dane, do you want to start?
Okay.
My name is Dane. For Dr. Worrell, for sampling the top layer of the micro layer, since you said it's like acts like carbohydrates or like oil on the top surface, how come you can't just take a sample and then bring it on board and then take the micro layer? If you break the micro layer, will it reform again?
Did you hear that?
Or
Okay. I think I heard that the question was that how we collect this film from the ocean.
Yes.
We have developed a catamaran, which is remote controlled from the deck. The catamaran has rotating glass disc between its hulls, and the glass disc, yeah, they're like half a meter in diameter, so they're pretty big, and they're partly immersed in the water, so they go constantly rotating through the sea surface and picks up this film, which is more, yeah, that will stick on the glass disc. And we have 6 of those glass discs rotating, and between those glass discs, we have wipers, which constantly remove the film from the glass disc to container where we pump it then through sensors and bottles, which we then bring on board to analyze.
So just the other question that I heard was, if you break the microlayer, will it reform? I think that was another question, kind of a follow-up on that.
Actually, that's a very good question. This film has been known for many decades. And only recently we understood that breaking waves actually reforms this film very quickly. If you can imagine, when a wave breaks, it will certainly destroy this film. But we learned already that this film are made of molecules which behaves like oil. So oil don't like water. It try to escape from the water and accumulate at the surface. When a wave breaks, it will entrain a lot of air in the underlying water column, and all the molecules from the film, which is pushed down by the breaking wave, will quickly stick on the air bubbles, because it's also an air-water interface, and will rise up with the air bubbles to the surface and reform the film very quickly.
All right, that was a great question. Did that answer satisfy the questions that were asked there, Ilani?
Thank you.
Yes, thank you. Can we ask another question?
Sure, go ahead.
Hi, okay, my name is Josh. Dr. Whirl, I heard you were doing research at the Institute for Chemistry and Biology of the Marine Environment at the University of Oldenburg. And I was just wondering how the research done on the Falkor could help your research at the university.
I'm not sure if I heard it now.
The question is connecting the research that you're doing on the Falkor to the research that when you get back to university. So how do you connect what you do when you're in the field with what you do when you're back at university?
Okay. So we collect a lot of data here on the Falkor, and we have a very busy schedule because we want to make use of the time to collect data. So basically, we will bring back the data home, and we will look carefully at the data. We will combine those data with other data sets we collect from other parts of the world. And our big objective is to understand the exchange of greenhouse gases between the atmosphere and ocean better through those data, and have those new data implemented in new climate models, so we can understand how climate change will happen in the future. Did I answer the question? I'm not very sure.
I think that was a good answer. Does that satisfy you?
Yeah,
Your question, Josh?
Thank you.
Okay. I actually have a question that has come in from Riviera Middle School for you as well. There was a question asking, so does the microlayer, does the film cause the water to hold additional heat?
Ooh, that's a good question. So we have another science team here on board. That's Chris Sapper's research group from Columbia University, who has infrared cameras installed on the Falkor, measuring the sea surface temperature. And usually we are talking about the cooling effect of the sea surface. Usually the very top is cooler than the underlying water because heat is transferred to water very quick. And the humidity will further cool down the very top of the ocean. So the answer would be no, the microlayer doesn't trap heat.
Okay. That was another great question that came in. So do we want to do one more question? I saw some hands go up at Iolani, but also I wanted to make sure Coventry got a chance as well. So let's get one question from each place, and then we'll move on to our next speaker, and then we'll have more time for a few questions at the end. Okay, guys? So who at Coventry has a question?
Hi, I'm Alexis. I'm in 8th grade, and I had a question. What's the #1 thing we can do right now to help the ocean?
That's a big question. So I think I would open it up to everyone on the Falkor, but what's the #1 thing that you guys would advise doing right now to help ocean health?
A very big issue right now in science in regards of the ocean is plastic. If you go in the middle of the Pacific, the big gyre is just full of plastic, which comes from different parts of the world, accumulating there through the different sea currents. Plastic makes our life very convenient. We find it everywhere. I think we all have to learn how to take care of the plastic if we don't need it anymore, to recycle it and not just to throw it where we just stand. Yeah, I think marine plastic as a marine waste is a big problem. Not because only it makes the water dirty. The most concern is about if you look at a plastic bag in the ocean, for a sea turtle, it looks like a jellyfish, really. And he will go for it. And he will get sick of it. So it will affect the ecosystem if we don't control what happened with our plastic waste.
Okay. So single-use plastics, does that answer your question, guys?
Yeah.
Thank you.
All right. And in Ohio? All right. I'm going to throw it back over to Iolani for one more question.
Okay, we have a couple more questions, but maybe we'll save some till the very end.
That'd be great. Let's get one person right now.
Okay, Ryota, go for it.
Hi, I'm Ryota. I'm a senior from Iolani School. And I want to know how different the microlayer was near shore, in the middle of the ocean and in different oceans. And if it was possible to replicate the microlayer in like a lab or at home.
Okay, so as I understand, you're wondering what's the difference between the microlayer near shore versus open ocean, and then also is there a way to replicate the microlayer in a lab? That's
Thank you for this very.
Go ahead, Dr. Worrell.
Okay, that's a very interesting question. It's actually one of the questions we try to answer here during this course, because right now we are still pretty close to the coast of Australia, and after this day we will actually head out in the open Pacific to actually answer this question: how does a microlayer differs between coastal and the open ocean? It certainly differs because the coast has significant effects on the coastal waters. It has more nutrients. More nutrients means the tiny plants and animals can grow better. We have different wind conditions, so we expect different observations. The second part of the question was to replicate a microlayer in the laboratory. We try to do that to understand some fundamental processes, but to exactly replicate a natural microlayer in the lab, I haven't found a way to do that, and I think it will be very difficult because the ocean is so complex. To simulate the exact wind condition the microlayer is exposed to is just at the moment with the technology we have impossible.
Okay, thank you. So we're going to shift gears just a little bit and talk to our third panelist right now. Not everyone is on board the Falkor as a principal investigator. So we've got a lot of different people that are the support that allow this research to go on at sea. And so we have Luke with us, and I'm going to let Luke introduce himself and tell us who he is and what he does. And I'm sure you guys will have some additional questions.
All right. Thank you very much. Good morning and good afternoon. I kind of feel like I'm doing karaoke right now with this microphone. So yeah, my name's Luke McNutt. I'm from the East Coast of Canada. And my role here on the Falkor is I'm a navigation cadet, so a marine navigation cadet. So my job is kind of split up into two different jobs, really. So half of the time I am working on deck. So I'm working with the deckhands, working with the bosun, who's in charge of all the deckhands. And we are responsible for all the maintenance on board Falkor. And we also help out with the scientific operations. So we are operating the cranes on board. We are driving the small boats, even things like painting and general upkeep of the vessel. That's kind of our main responsibilities. As a marine navigation cadet, what that means is I'm training to be a navigational officer. So I'm training to basically be on the bridge driving the ship. So the other half of my job is spending it with the chief mate or the captain or the other officers, and just basically learning all the navigational equipment. For one day being able to keep a watch by myself and be a third mate or second mate or chief mate, and eventually someday become a captain of a ship like this.
Okay, look, and there's a picture behind you of some work, I guess, that you've done recently that Deborah pointed out. What's going on over there?
Yeah, so this is, on this particular cruise, this is what a kind of a typical day looks like. So this is me driving our work boat, and we have a nice kayak on board. We have some scientists on the back of the boat there, and then we have another crew member, Al. So what we're doing here is we're driving the scientists away from Falkor, and what we do is we put them on the kayak, and they kind of paddle away from the ship a little more, and they collect water samples. The reason that we do this is we want to get them away from the ship so they can collect clean water samples, so they're not tampered by the ship, any pollutants or anything that might be on the ship. So this is my typical morning looks like. So I'll be out around 6:30 a.m. doing this kind of thing, and then again when I come on for my evening shift, I'll be back out on the boat around 5 p.m., 6 p.m. for another couple hours.
Okay, cool. So, Iolani or Coventry, are there questions right now that would go to Luke or?
We got one here, Stacey.
All right, great.
Okay, my name is Mark. I'm in 8th grade, and I wanted to know who does the cooking.
Okay, so Mark is interested in the cooking. I'm sure that
Okay.
And actually Deborah promised us we would find out more about that.
So who does the cooking? Well, they don't let me do the cooking, unfortunately. I do enjoy cooking, but they don't let me. No, we have 2 chefs on board. So those are 2 dedicated chefs, very, very talented guys, and they make sure that we're well fed every day.
Thanks.
We have a question at Iolani if you're still taking questions.
Go ahead.
All right.
Now, does the micro layer ever change in different conditions?
The question is, like weather conditions?
Yeah, does the micro layer ever change?
Does it change in weather?
Okay, does the microlayer change according to weather conditions, I think is the question.
Good question. It's kind of outside of my department, being somebody that is basically learning how to operate and navigate the ship. So I could hand that over to Oliver. Probably better answer that question.
Thanks, Luke.
Yes. The microlayer change with different conditions. It primarily depends on the blooms of plankton. Plankton are tiny plants in the ocean, which excrete those molecules accumulating at the sea surface, making this microlayer. And it also depends on the wind. The wind applies some forces on the sea surface, and if the wind increase the microlayer, as we said, the breaking waves will disperse some of the material. But when the bubbles rise up, it reforms very quickly. So yes.
Good answer. Okay. All right, we have one more question for Luke, who drives the boats or is learning to navigate, right? Yeah. Why don't you ask it? Go for it.
So then, driving the boat. I didn't even think about how to phrase it. How do you have shifts, or do you just stay awake driving the boat the whole time, or do you have like autopilot or?
Yeah, good question. Are you referring to the small boat you're seeing in the picture, or Falkor as a whole?
Falkor as a whole.
Falkor, yeah. So when we're at sea, our time is broken up into shifts. So the typical shift at sea is 4 hours on and 8 hours off. So take now, for example, this cruise. I'm on the 4 to 8. So I work from 4 a.m. to 8 a.m. and then from 4 p.m. to 8 p.m. Now, these numbers can change. Typically, you don't just work 8 hours in a day. So I'm also on standby for 4 hours. So typical day, you're going to be most likely working more than 8 hours, but that's kind of how it's broken up. The reason they do that is because when you're up on the bridge navigating a ship, they want people to be awake and alert. So they don't want people up there for 7, 8, 9 hours doing the same job. Especially at nighttime, it can get extremely sleepy up there. So always having fresh people, people that are awake, that ensures that we can navigate the ship properly.
I'm going to ask a follow-up question that has come in from Florida, and it is directly to you, Luke. Is there an education path? Are there classes that someone should take to follow your career path?
Yeah, absolutely. So what I did is I went to a Marine Academy in Nova Scotia, where I was born. And the program I took was called Marine Navigation. So this is a 3-year course. Depending on where you take it, it can be 2, 3, or 4 years, depending how intense the years are. But yeah, I trained for 3 years from September to May. And then how it works is I go to school September to May, and then in the summers, I come on board a vessel like Falkor, and I do some on-the-job training. And then after the summers, I go back to the classroom and so on and so on. So I just finished my 3 years of training, and now I'm working on my sea time in order to take my exam to work as an officer. So I need 12 months in total at sea, and I'm currently around 10 months. So I'm almost there. But my recommendation would be, if anybody's interested in being a navigator or even an engineer, a marine engineer, is what you can do is you can go to your nearest nautical school and talk to some of the teachers. Usually in these schools, the teachers are ex-captains, ex-chief engineers, so they can really give you a good idea of, you know, if you want to go down this path, what it's going to be like.
Great, thank you. So I'm going to shift over to Coventry, and guys, we probably have time for maybe one more question from each classroom. And if you guys have additional questions, then I would be happy to, if you can have your teachers email them, and I will send them out to the Falkor, and we'll get some answers for you. So who do we have at Coventry that has a question?
I'm Maya, and I'm in 8th grade, and I wanted to know what one of the biggest discoveries you've had.
What is it?
Is there somebody in particular you want to ask?
Deborah?
Okay, so just say again.
Deborah?
Deborah, what's the biggest discovery you've worked on? What's the biggest kind of aha cool thing?
Well, I've only been here 3 months, so no, I know the ship actually did quite a bit, and because mapping is my background. So Hunga Tonga is the newest piece of land on Earth that's now coming up above the water. And so the ship was able to, in this last year, map completely around that, and that data, in conjunction with the scientists aboard and NASA, we're really excited to get some high resolution multi-beam on that. And also the ship has done a bit of exploration into vessels. So the Scott's expedition off of to this Antarctic, that ship that was sunk, the ship founded on their initial voyage from the launching of the vessel to the east coast of the U.S. So it was just off of Greenland. So I know there are a number of different really great expeditions, but I think really one of the most recent really neat things was to be able to map sort of that newest bit of land on Earth, just creating into a new volcano.
Yeah, that's very cool. So, and there are some blogs on the Schmidt Ocean Institute's website, right, Deborah, on that?
Yes.
Cruise as well. So that
Yep.
If you want to learn more
and there's
about,
lots of.
Go ahead, Deborah. I'm sorry.
No, sorry. So there's lots of blogs, and all of the past expeditions are up on the website, so you can see pictures and read information from a lot of the work that the Falkor has done. There's also a ship's tour. So if there are places and spaces on the ship that you want to see, that's a really good way to kind of peek inside the vessel.
All right, I'm gonna Iolani, do you guys have one more question? And then we've got one. Well, we've got about 5 from from out there that I'm going to get answered eventually, but we'll do one more on camera. So Iolani, do you have anything?
So just a general kind of, we weren't sure if this was possible, but in terms of the virtual tour that you said was online, we were wondering if maybe at the end we could walk around a little bit and see what it looks like on the ship. Like if their camera's mobile or if it's an iPad, just take us down like the corridors or like look into the lab or something like that, just to see what the ship is like.
Yeah, unfortunately, because of the way the internet is working, we needed to stay stationary here in the library. So the more that we try to move around on a tablet, the harder it is for us to sort of focus that internet access to be able to broadcast to you guys. So unfortunately, we can't do a walking tour. But really that virtual tour is it. I mean, you can in 360 feel like you're walking around the ship and see spaces that you wouldn't normally be able to from just us walking around, like the engine room and things like that. So you may not see people working in those spaces, but it does give a pretty comprehensive walkthrough of the ship.
Okay, great. Can we ask one more question then?
Oh, wait, no, I have a question.
Go ahead, guys.
Yeah, Juhei.
Hi, I'm Juhei. I wanted to ask how the discovery of the discovery that might happen about the sea surface microlayer will impact our understanding of climate change right now.
So the question is, how does the study of the microlayer impact our understanding about climate change? Yeah. Did I hear that correctly?
Yeah.
Okay, I think that's for you, Dr. Worrell.
Yeah. Well, we know that the microlayer should have an effect on the exchange of all kinds of material between the atmosphere and the ocean, because it's just between those two. And but the difficulties are to have a good set of observations. And this cruise on the Falkor is actually the first where we have scientists from different disciplines on board. We have microbiologists, we have physical oceanographers, we have chemists. And we really hope that with this cruise, we can get a better understanding on how this thin layer between the ocean and atmosphere affects climate change or controls climate change. And so we hope to have a better answer in a couple of months when we have all our data and know what those data means.
Thank you, Dr. Worrell. I appreciate that answer, and I just wanted to go ahead and make sure that we were really conscious of time. I know we've still got about 6 or 8 questions that are coming from classrooms, but we do have to wrap it up. We ran a little bit over today, but what I'll do is any questions that your teacher sent to me and the questions that we got live in our questions form, I will follow up with our panelists and get some answers for you, and we'll send them back out via email. Because we do have that information, and we'll post that in this same spot with a recorded version of the event, the virtual field trip that we had today. So, but with that, we are at a point where we're a little bit out of time. And so I wanted to thank our panelists. They got up at 4 o'clock in the morning for you guys. So that's that. For sure. And for those of you that are interested in learning more, you can visit earthecho.org for more information on a few of these topics. And also there are really fantastic resources at the Schmidt Ocean Institute's website as well. You can see past cruises, cruises that are coming up, and we will continue to work on doing more of these Google Hangout events, and have 2 that are scheduled already. So we will be doing another one that will be on December I'm checking the date right now, December, oh my goodness. So we've got one that will be about their ROV that is on December 7th at 2 p.m. Eastern. So it's ROV Sebastian in action. And then on February 2nd, we will have another that is back to the surface. So please stay tuned and join us for those events as well. And with that, everybody have a great day. Thank you to Coventry Middle School. Thank you to Iolani School. I really appreciate everybody being online, and we'll see you on the next one.
Yeah.